All right, guys. Up on the new whiteboard here, so it's a different side of my classroom. I kind of set 2 videos up so I can get them done quicker for you guys. So we are going to do, and I didn't bother to write it up here, we're going to do 11-8. This is part 2. And this is all of it together. This is our vertical translations, it's all putting it all together. It's doing our phase shifts, our period shrinking, it's everything all in one. So let's go ahead and tackle this. So this is part 2, 11-8. And it says state the amplitude, the period, the phase shift, and the midline. And then you're going to graph the function. So let's just kind of work with some information here that we already know. We're going to do probably 2 to 3 of these, and then we'll do one of them, and then you guys will try one on your own, and then I'll do one more to show you, and then we'll keep working on these. All right, so let's look at this. So let's take our information. My amplitude is 3. It's a number that's in front. It's from our previous lectures. My B is 2/3. So my B is equal to 2/3. So now it changes things. So now my period is going to change because my period is 2 pi over 2/3. This is why we worked on our complex fractions. That's going to flip over and become 2 pi times, I'll give myself some room here. This is going to become 2 pi over 1 times 3 over 2. So my new period is 3 pi. That's important. My new period is 3 pi. So I'm going to write that down right now. I normally start at 0 and I end at 2 pi. But considering I have this b, I have to move it to 3 pi. So we're going to be over here at 3 pi. This is not degrees, this is radians. So this is 3 pi right there. Okay, so now, normally it goes to 1, 2, it normally only goes to 2 pi. But now it's going to go all the way to this green one here. So that's the period. All right, let's look at our phase shift. We'll do that in red. Our phase shift is right here. It's always the opposite. So our H for our phase shift is pi. Opposite of what you see there. That's negative pi, we're getting pi. All right? Pi sounds really good right now. All right, now, so now I've got a phase shift of pi, and then my midline is 4. So my vertical shift tells me my midline is at 4. Oops, 4. I can't. 4. Okay, so. All right, so let's work around this stuff here. So you can do a bunch of different things. So what I'm gonna do first is I'm gonna draw my midline. So my midline is 4. So if I go up to my midline, 1, 2, 3, 4. My midline is 4. My amplitude is 3, so I have to go up 3. 1, 2, 3. So at 7, so 4 plus 3 gives me my maximum line. Then I'm going to do 4 minus 3. That's going to give me my minimum line. Now my midline is right here. There's my amplitude, 3 up, 3 down. Now all I have to do is figure out where my points are now. So I did a shift of 3 pi. I mean an expansion of my period to 3 pi. So it's supposed to go from 0 to 3 pi, but I have to do a phase shift that way, pi. So if this is pi right here. So if we look at this in red, my starting point's normally at 0, but now my starting point is at pi because 0 plus pi is my new starting point. Okay, so 0 plus pi is my new starting point. So my new starting point's here, and my new ending point which is my x2, and we can call this x1. So this is going to be pi. My new x2 is going to be 3 pi plus pi, which is 4 pi. So if I move over here, I'm going to go to 4 pi. So now my period is still 3 pi, because 4 pi minus 3 pi, but I shifted it this way, pi. What does sine do? Sine goes midline, maximum, midline, minimum, midline. All right? So let's do this graph in blue. So we go to my new starting point, which is x1. It's right here. Midline, maximum, midline, minimum, ending point. Ugly looking graph I drew, but that's how you do it right there. So now I've got a sine graph that's shifted to the right pi, moved up 4 with an amplitude of 3. Don't forget, the distance from here to here is 3. The distance from here to here is 3. The distance from here to here is pi. So I want you guys to try number 3, guided practice on page 699. I'll copy and paste like I did before and put the answer there. And then I'm going to do one more for you guys, and it'll be a cosine graph, I think. Yeah, cosine graph. Nope, that's not a cosine graph. Let me find one for you guys. I'll do one of the even ones in the book. Yeah, that's what I'll do. All right, so here we go. I'll find something for you guys. Where'd my... I don't know where my eraser is, guys. I'll set it down. Here we go. All right, so let's do this. You can fast forward through that. All right, so let's write this down. Let's graph y equals 4 cosine 3/4. No, let's go. I don't like that one. Yeah, let's do 3/4. No. Let me think about this. Theta minus 2 pi all over. You know what? I'm going to check something on you guys right now. Yeah, let's do one. Let's do this. Let's change this, guys. Pi over 2. I'm trying to come up with problems that you're going to see on your homework. They go with pretty nice numbers, so we'll just go ahead and call this 3. Call that 3. Okay. Let's do that. So, oh, and then we're going to do plus 2. All right, so here we go. Our amplitude is equal to 4. My, I'll do midline right next to it. Midline is equal to 2. Now my x stuff, my period is going to be 2 pi over b, which is 3. So that's my new period. And then my phase shift, is pi over 2. H is equal to pi over 2 because it's the opposite of what we see. All right, so let's tackle this. This kind of gets a little tough sometimes because we're going to start dealing with fractions. So let's draw this out, guys. This is why we did fraction review the other day. Let's draw this out. Let's talk about where it's at. So we start at 0. and we're supposed to end at 2 pi over 3. That's where it's supposed to be. We got our 4 points right here. All right. It's supposed to be at 2 pi over 3. That's how long it is. So this is my x2 right now, and this is my x1. But we're talking about a phase shift. So for the phase shift, we got to mess with it first. So my x1 becomes 0 plus the phase shift, which is pi over 2. So my x1 is now at pi over 2. Go to this one. My new x2 is 2 pi over 3. Remember, this is in radians. And the reason I call it x is because this is the x-axis. 2 pi over 3 plus the phase shift, pi over 2. So now it's like, oh man, how do I solve it? It's a fraction. No worries, guys. 2 times 2 is 4 pi plus 3 times pi is 3 pi all over, what's 2 times 3? 6. Replay that if you need to. I'm going to say it one more time. To deal with this, bottom right denominator times top right numerator. 2 times 2 is 4 pi. Bottom left denominator times top right numerator. 3 times pi is 3 pi. Multiply your denominators. You get 6. Add the two together. You get 7 pi over 6. So I'm going to go ahead and circle these in red because I want to orange. I want to do them in orange. So I'm going to go there, and I'm going to go here, and I'm just going to move it over about pi over 2. So let's just go right here. Don't have to be perfect, guys. That's pi over 2. That's my x1. This is my x2, which is 7 pi over 6. So now I know that my midline is going to start at my x1. My midline is at 2. So I'm going to go up to 2. And my midline's right here at 2. So that's my midline at 2. And I know my amplitude is 4. 1, 2, 3, 4. It's up at 6. 1, 2. This isn't going to look right. I'm going to have to erase that. 1, 2, 3, 4. That's at 6. 1, 2, 3, 4. It's down here at -2. So my minimum is going to be ugly. It's going to be all the way down through here. My maximum is going to be all the way up here. And my starting and ending points are at pi and at 7 pi over 6. Okay, so what does this graph do? It's a cosine graph, so it goes maximum, midline, minimum, midline, maximum. Maximum, midline, minimum. Oops, I got a curve. Looks something like that. We're just sketching them, guys. All right? So I would probably do this work off to the side. I didn't realize I scaled it funky, but that's kind of how you tackle the phase shifts and all the different pieces there. So good luck, and we'll see you soon.